Hi everyone, welcome to the podcast series of Humanizing Machine Learning. In this podcast, we are going to discuss about supervised machine learning algorithms. Specifically, we will talk about the importance and logic behind forming a training set and a validation set for a supervised machine learning algorithm. Let's first start with what is a training set. Tell me one thing. How do you train your little brother, say for classifying cars and trucks? You show him some examples of cars, or I would say some samples of cars, and let him observe its features, say the size, structure, color, or window size. Similarly, you show him some different variety of trucks and let him observe the features of trucks. What did you do? You trained him to classify cars and trucks. And how did you do that? You gave him the input, which is the samples of cars or trucks, and you obviously know what you were showing to him. You know when you gave him a car versus when you gave him a truck. You also know your input and your output you want out of him. So, what was your input? The samples of cars and trucks, and what output did you expect out of him? On which you obviously knew as well whether the sample is a car or a truck. This is how training works, and the group of these cars and trucks shown to your little brother is called a training set. Simple, right? Now, suppose your little brother has got trained. He used his best observation skills, and now he's asking you to take him for exam at his school. Before taking him to exam or to face his teachers, would you like to know if he has learned properly? Well, for that, you again arrange some more samples of cars and trucks which he had not seen earlier while you were training him, and you ask him to classify these. You, the trainer, knows the expected output. You want to hear car when you show him a car and a truck when you show him a truck. So again, you know your input and output. After asking him to classify a few more samples and checking his performance, you decide to take him to his school for his final examination. As simple as that. So, do you know what you've just learned from this example? You know what is a training set. The first set of examples your brother saw and observed the features of was your training set. You also know what a validation set is. The set of examples you judged your brother's performance on was your validation set. And after your brother has performed well on the validation set, you put him to classify more examples in his school examination, where you would obviously not be present. So you just learned what training and validating a machine learning algorithm is. Let's get into some more depth. How will you check for your machine learning algorithm's validation performance? Well, it's done using a number called accuracy, which is equal to number of samples classified correctly divided by the number of samples given to the machine multiplied by 100. So if your machine classifies 90 samples correctly, that is out of 100 samples of trucks and cars, 90% of times it could give the right class, then its accuracy comes out to be 90%. You know that machines don't use eyes, right? Like we humans do to observe trucks and cars. Machines do not have such eyes, and rather they work on numbers. So how do they learn features of any given sample in form of numbers? I think we can cover it in our next podcast. For now, let me tell you how to construct your training set. Remember two things. Your training sample should contain each class. That is, if you want your algorithm to classify A, B, C, you need to present examples from A, B, C during training. Next, use a variety of samples. For example, if you want your algorithm to classify Indian faces versus American faces, present examples from all over India, not just from southern part of it. The same applies to samples of American faces. And did I mention that validation set and training set should have different samples? Think of your little brother's training again. So in the next podcast, we are going to understand what's called a feature space. How do we quantify features? How do we feed in numbers or these features of samples in form of numbers to our machines? We are also going to understand the basics of neural network in the form of perceptrons.